back everybody to the next question. So they have asked about which of the following equation is right for the identity for matrices 3 cross 2 matrices, is it right? So from the option we do select, okay, so given 4 options, A option. So before I enter the option, I will tell you something about identity. So identity represents, suppose if I have one pen and same as that of pen, there should be 2 pens. It should be equal, okay. So when you take off any equations, if you have left hand side and right hand side, LHS, RHS, in that RHS if you have 1 means, the LHS if you have 1 means RHS there should be of 2. So 2 can be written as 1 into 1 or sorry 2 into 1 or 1 plus 1, while the identity as that of the left hand side, is it right? The same way. So what I should say, if I have 2 plus 1 in the left hand side, you have to write 2 into 2 plus 1 or otherwise 3 into 2 plus 1 or 4 into 2 plus 1. The 2 plus 1 should be the constant, okay. It can be multiplied by any type of factors or it can be added by any factors, but that 2 plus 1 in the left hand side and the 2 plus the right hand side should be the same, should be continuity for all the coming successive steps. Now in the same way, from the 4 options I have to select a particular option. From that option, the both left hand side and right hand side should be have the same normal, okay. When I see P of Q plus R, it should be changing to PQ plus RP. So there will not be any Q plus R here. So if you take common of P, you can have Q plus R. But no problem, don't worry. Is it right? But you cannot have the Q plus R right. If you do so, it will be equal to that of the left hand side. That should be equal. But I don't want the equal. I want the identity. That should be out. Identity represents the left hand side should be the same, but right hand side should be enormous. It should be gross on. When you look at P minus Q the whole square, I can write P minus Q in the form of P plus Q into P minus Q. Is it right? Then what it will give the P minus Q the whole square. The A plus B into A minus B, which will be in the form of A minus B the whole square. I'm sorry, A square minus B square. So it can't be possible. So P minus Q the whole square cannot be possible. And I have the determinant of P plus Q. Determinant of P plus Q I cannot write in any form in the right hand side. So I'm sorry about the third option. Third option is also not right. And next one, P plus Q the whole square. Yeah, now I can find the answer. P plus Q the whole square I can write in a good way. So P plus Q the whole square, which will be equal to P plus Q into P plus Q. Yeah, easily I can write. So look at it here. In the left hand side also there comes P plus Q. In the right hand side also there comes P plus Q. So the P plus Q term is repeating in both sides, left hand side as well as right hand. So this is about the identity because this gives the same value. Yeah, sure. So when I do so, if I do multiply, what I have P square and afterwards plus QP, or you can write PQ because everything is commutative, and afterwards Q square. So this P plus Q the whole square, which will give this type of a matrix, because each P matrix and Q matrix is said to be a 3 cross 3 identity matrix. Okay, so according to me, all the options are right, but they aren't identical. They are not identical because the question they represent the correct identity. So I have to select, I am supposed to select the option number 4. Option B is right. We may see the next question. Thank you very much.